Alright, this is the seventh video where we're looking at solutions for the handout using the index of refraction, handout 1. Question 7 reads, a physicist does an experiment on some new experimental lenses. She finds that the speed of light in the material is 2.75 times 10 to the power of 8 meters per second when the light enters the lenses at an angle of 30 degrees. That's the incident angle. How fast is light? What is the angle of refraction in the experiments? We're trying to find R. Another thing that we don't know is the index of refraction for the material, so we're going to have to calculate that. One thing that we do know is that the speed of light in a vacuum is always 3.0 times 10 to the 8 meters per second. Some formulas that we can rely on are C equals N equals C divided by V, okay, and N equals sine I over sine R. Okay, so you can see here that we have the speed of the light in the material and we have the speed of light in a vacuum. So we can use this formula first. So we can just substitute our values right in here. So we've got 3.0 times 10 to the power of 8 meters per second divided by 2.75 times 10 to the 8 meters per second. Okay, now we can plug all of this right into our calculator, but notice that 10 times 10 to the power of 8 is found on both the top and the bottom, so we can just cancel those two parts just to simplify what we have to write into our type into our calculator. And let's take 3 divided by 2.75 and we get an answer of 1.09. So the index of refraction for this particular substance is 1.09. Now what we have to do is find what the angle of refraction actually is. Okay, so we're going to have to rearrange this particular formula here. So let me kind of wipe that out and give ourselves some room. Let's write down that the index of refraction is calculated to be 1.09 over here, so we don't forget it. And let's rewrite N equals sine I over sine R. So what we have to do now is rearrange this equation to isolate sine R on one side. So the way that we can do that is to multiply both sides by sine R. Okay. And what will happen is they will cancel on the right side. And when we rewrite this thing, it will be sine R times N equals sine I. Now what we want to do is divide both sides by N as follows. These N's will cancel on that side and we're left with sine R equals sine I over N. Now what we can do is substitute our values. So we've got sine I will become sine 30, and the index of refraction that we calculated was 1.09. Okay, so take our calculator and hit sine 30 and we get an answer of 0.5 over 1.09. Okay, so take 0.5 now and divide it by 1.09 and we get an answer of 0.4587. Let's round that to 0.459. So sine R equals 0.459. So how do we actually count the angle of refraction? So what we do is we hit second function, press sine here because above the sine button there's sine -1, so we find the inverse of it, so press that. So you can see here sine to the power of -1, and now press 0.459, and we get an answer of 27.3 degrees.